Hello, hello. Hello, everyone. Am I live? Hello, hello. Hello, everyone. Am I live? Hello, everyone. Hello, and welcome back to our channel. So, in our today's video, in our today's class, this is going to be a long class, and as your re-NEET exam is just 2 days away, so what we are going to do in this class is that we are going to do this physics revision marathon in two parts. First is our today's class, and the second part will be covered in the tomorrow's class. So, what we are going to do is in our today's class, we are going to revise all the chapters of class 11th, right? Like starting from units and dimensions, we are going to cover everything till oscillations and waves. And then in our tomorrow's class, we are going to revise all the chapters of our class 12th physics. So, I hope all of you are doing good and your preparation for your re-NEET exam is going really well. And like at this point of time, I would just advise you that keep calm, stay focused, don't take any unnecessary stress, or don't watch too much news. And I know a lot of things are going on around you, but just don't focus on them right now. Your focus should be on one thing, that is your revision for the re-NEET exam, right? So let's start with our today's class. We'll start with the very first chapter, that is units and dimensions, and then we'll continue further. So, I hope all of you have your spirits and your motivation high. So, let's start with the very first chapter. The very first chapter being units and dimensions. So what we are going to do is, like, what I have planned for now for today is that we are just going to revise the chapters, and we are not going to, in between I'll keep on discussing some of the other questions with you people, but we're not going to discuss all the questions or PYQs in detail. So the very first chapter is going to be units and dimensions. So we know that units basically, if every fundamental quantity, so every quantity can be measured, and every measurement has got two things. The very first thing is that there can be two physical quantities. There can be two types of physical quantities. First type being your fundamental quantity, and second being your first is your fundamental quantity, second is your derived quantity, right? Fundamental quantity is something that cannot be expressed in terms of any other physical quantity. And derived quantities are those quantities which can be expressed in terms of other fundamental quantities. We studied that there are seven fundamental quantities, right? Mass, length, time, electric current, temperature, luminous intensity, and amount of substance. So you've got seven fundamental quantities which cannot be expressed in terms of other quantities. And apart from these seven, whatever quantity you know is a derived quantity. The word derived is basically it can be derived from fundamental quantity. Then every physical quantity can be measured. Anything which can be measured is a physical quantity, and every fundamental or every physical quantity can be measured. And every measurement has got two things. Every measurement, this is the amount of a quantity q, and every quantity has got two things. Every measurement has got two things. First is the numerical value, which is represented by n, and second is the unit, which is represented by u. And over here we see that the numerical value is directly proportional to the amount of quantity. Unit is directly proportional to the amount of quantity. That means A bigger numerical value will represent a bigger physical quantity. A bigger unit will represent a bigger quantity, right? And if your amount of quantity, like amount of substance, or your measurement of a quantity is fixed, if q is constant, in this particular case, if q is constant in this particular case, your numerical value is inversely proportional to your unit. That means bigger unit will have a smaller numerical value and smaller unit will have a bigger numerical value. One example for this could be 1 kg is equal to 1000 gram. Kg is a bigger unit, it has got smaller numerical value, that is only 1. Then gram is a smaller unit, so it has got a bigger numerical value, 1000, right? So these were the two important things which we studied on the part of units. And then there were two exceptions. You just have to remember the exceptions very carefully. There were two quantities. First was your plane angle and second was your solid angle. So ideally, they should have been unitless quantities, but they are not unitless. Why would have they been unitless quantities? Because they are the ratio of two same physical quantities. Plane angle, it can be calculated simply by arc upon radius. Arc length divided by radius. Both of these are lengths, so it should have been unitless, but it is not. It has a unit called radians. Then solid angle, similar case for solid angle also. The unit for solid angle is steradians. These are the two main exceptions, solid angle and plane angle. You just need to remember them very carefully. This was the first part of this chapter in which we discussed what are units and like how do we measure a quantity, what does a measurement comprise of, right? And then there was a small topic called significant figure. I'm sure that you people must be very clear with significant figure. So hardly matlab, I believe like hardly one single question may or may not come in your exam from this topic, significant figure. You just need to remember 2 to 3 rules for significant figure. Every non-zero digit is significant. Zeros are significant if they are in between two non-zero digits. And then you have to take care of the decimal. Any zero or any digit after the decimal point. For example, decimal point is over here. Then after the decimal point, towards the right of the decimal point, every digit, be it non-zero or zero, becomes significant. On the left, there are some, to the left of decimal, there are some rules which you have to follow. So this was all about units and measurement. And measurement part also had two things, accuracy and precision. Accuracy means the closeness of any measured value to the true value. Precision means to what precise value or to what number of decimal places you can calculate the particular value or you can give the measurement, right? Then the second part of this chapter was dimensions. So dimensions basically meant the power to which the fundamental quantities should be raised in order to represent that particular quantity. For example, I say I have volume. So the dimension of volume is 3 in length. That means this shows that volume comprises of 3 lengths, right? So 3 was the dimension of volume in length. Length is the fundamental quantity. L cube was the dimensional formula, and this V is equal to, if I put if I put quantity on one side of the equation and dimensional formula on the other, then this whole thing becomes a dimensional equation. On the part of dimensions, you get simple basic questions, and mind it, I believe like for this year, my prediction says that you will get at least 5 to 6 questions from this part, from dimensions. In dimensions, 2 to 3 types of questions may come, that they might give you some equation. For example, x is equal to at square plus bt. And then they tell you that x is your position of a particle and t is your time. A and B are two unknown quantities, and then you have to find out the dimension of A and B. So, by principle of homogeneity, we know the dimension of x should be equal to the dimension of at square, and this should also be equal to the dimension of B into T. I know x is position, so it has dimension L. A is an unknown quantity, time has dimension T, and we have square of time, so T square. So, the dimension of A comes out to be LT minus 2. dimension of B comes out to be LT minus 1, right? Dimensional formula. First is this basic thing. Second, in the same question, they might ask you to identify the fundamental quantity, the physical quantity. That what does A represent, what does B represent. So B has a similar dimensional formula as velocity, and A has similar dimensional formula as acceleration. So you might say that B represents velocity and A represents acceleration of a particle. Then the second type of question which usually comes is, this is first type. Then the second type of question which usually comes is that they will, give you some formula or some equation. For example, V into E divided by M square. And they will tell you that what does each symbol represent. For example, you are given V represents velocity, E represents energy, and M represents mass of the particle. Okay. You have to find out the dimensional formula for this very quantity, VE upon M square. You don't have to do anything, you just have to put the dimensions, simplify, and you will get the answer. For example, dimensional formula of velocity is LT minus 1. Energy is, you'd never ever try to memorize the dimensions. You should always focus on, deriving the dimension using the formula. As soon as you see any fundamental, any physical quantity, you must have completed the complete chapter, the complete syllabus, right? For class 11th as well as for class 12th. So what you have to do is, as soon as you see any physical quantity, you have to go to that chapter. You have to, memorize or recall the formula for that quantity, and then you have to derive the dimension for that quantity. For example, I have energy. Energy and work are same thing, and work is basically force into displacement. Dimensional formula of force is mLT minus 2 and multiplied by dimension of L. So it simply becomes ml square t minus 2. So ml square t minus 2 and divided by m square. You just need to simplify it. Whatever answer you get, that is your final answer. You need to take that particular option. So these are the two basic type of questions which might come solely based on the dimensional part. Then the other thing could be that you might get some questions on the applications of dimensional analysis. So there were primarily three applications. First was checking the dimensional consistency, but since it is a objective exam and not a subjective exam, so you might not get a question directly on checking the consistency, but you might get a statement based question or a assertion reason type question from this part. So checking the consistency, it basically told us that if the dimensions of L on LHS are equal to the dimensions on RHS, like we're talking about the complete dimensions after solving the question, then the equation is dimensionally consistent, otherwise it is not, right? So yeah, so for the last question, I think someone is asking the answer. So this becomes m minus 1 L cube and t minus 3. This will be your final answer for this question. Now moving forward for application, so checking the dimensional consistency was the very first application. Then second application was conversion of units. Conversion of units, it basically comprised of converting, for example, 1 Newton to dyne. Like we got three system of units, CGS, MKS and FPS. So using those three things, like interconverting the things, the physical quantities between two systems. Mostly you get MKS to CGS conversion most of the times. Okay. So like 1 Newton is the unit in MKS, dyne is the unit in CGS. Newton is the unit of force. So you can just simply use the formula, the dimensional formula. So force dimensional formula is mLT minus 2. So what you have to do is, you take mass. For Newton, mass will be in kg. Newton is the unit in MKS. 1 meter and 1 second minus 2. And then you have to convert it. For example, I say I get value n. In 1 gram, 1 centimeter and 1 second minus 2. Now the unit of time is same, seconds in both the system, that gets cancelled out. You can convert kg to grams. Always remember to convert, bigger unit to smaller unit, because this is a simple human error can occur if you try to convert a smaller unit to a bigger unit, because it has got negative powers. So in a hurry, you might commit some mistakes. 1 gram, 1 centimeter. Now you see centimeter gets cancelled with centimeter, grams gets cancelled with gram. The value of n comes out to be 10 raised to the power 5. That means I can say 1 Newton is equal to 10 raised to the power 5 dynes. Simply you can get a question on conversion of 1 joule to ergs or any such similar question. So this was the second application of your dimensional analysis. Then the third and very important application was derivation of formula. Now this same question can come. Only difference between subjective and objective exam is, like, for your re-NEET, they might ask you only the formula, because of course you don't have to write the process, but you can be asked to find out the formula, right? So like they might say that force depends upon mass, momentum and energy, let's suppose. So force depend on these three physical quantities. You need to derive a formula for force. So what we used to do is, we say that force is equal to mass raised to the power A, momentum raised to the power B, energy raised to the power C. Then we put in the dimensions on both the sides. Dimension of force is mLT minus 2. Dimension of mass is m raised to the power A. Dimension of momentum is LT minus 1. MLT minus 1. Momentum is basically mass into velocity. So mLT minus 1 raised to the power B. And then energy mL square T minus 2 raised to the power C. Then we used to simplify it. mLT minus 2 over here. M has got power A plus B plus C. L has got power B plus 2C. T has got power minus B minus 2C. Then we used to compare the dimensions, the powers of M, L and T on both the sides. So we say 1 is equal to A plus B plus C, 1 is equal to B plus 2C, and minus 2 is equal to minus B minus 2C. So you can simply write as 2 is equal to B plus 2C. So like this is a question which I only created. So like you can see this discrepancy, but like I was just explaining you the procedure. Then you can simply solve the for value of A, B and C, and then you will get the answer. So these were the main important things from this chapter, and this is the similar type of questions which you will get from this chapter. Just make sure you remember all the formulas. Like if within dimensional analysis or within the a question on dimensions, you might need the dimension of coefficient of viscosity, resistance, conductance, electric field. So you just have to be comfortable with calculating or deriving the dimensions of these physical quantities, right? Moving forward to our next chapter. So the next unit, it was basically kinematics, and within kinematics we had two chapters. First was motion in a straight line. If you are moving just along the along a single dimension, so motion in straight line, or we also can used to call it 1D, motion in one dimension. And then the second was motion in a plane. So plane is basically two-dimensional motion. In motion in straight line, we just simply considered either you are just traveling in x or you are just traveling in y. You are just traveling along a single dimension. In motion in a plane, we considered that you are moving in both the dimensions, in both the directions, x as well as y, simultaneously. That means you are like moving somewhere in this plane, in xy plane, right? So within motion in straight line, we first started by understanding the the definitions of some basic terms. So basic terms were, I'm not going to write the dimensions, the definitions again, but we're just going to revise it. The very first thing was, what do we mean by motion? So motion is whenever the position of a particle changes with respect to its with respect to time. So what do you mean by motion, and then what do you mean by rest if the position of a particle does not change? Like, why am I revising the definitions again? Although it is an objective exam, that you might get some statement based questions or some assertion reason types questions, or you might also get some questions wherein you have to choose the, like, correct option, or if a first statement follows the second, those type of questions you might get. So for those questions you have to be very well versed with the definitions. Then what do you mean by distance and displacement? Corresponding to distance and displacement, what do you mean by speed and velocity? So distance was a scalar quantity, speed was a scalar quantity, displacement was a vector, velocity was also a vector. Speed was basically equal to distance upon time, velocity was displacement upon time. Distance was the actual path traveled or the total path traveled, displacement was the shortest path traveled, right, between the initial and final point. Then speed was distance traveled per unit time, velocity was displacement per unit time. Then there were two concepts, average speed and average velocity. The formula remains similar but not same. Average speed and average velocity. Average speed is total distance upon total time, average velocity is total displacement upon total time. Now, what is the difference between average and instantaneous? For example, you are given, you have to go to A to B point, but you take a stop at a market in between, right? So and this is exactly in the middle. For example, you cover the first half of the distance, that is from A to M. You cover this distance with the speed of 20 meter per second, and then from M to B you cover this distance at the speed of 40 meter per second. Now the question asks, so these are the speeds for these defined intervals from A to M and from M to B. But the question might ask you that what is your average speed for the whole journey, that is between point A to B. So there were two formulas for average speed. Two formulas were, like, one formula was simply the formula of average. So average is basically when you cover equal distances. First formula, you just need to remember the formula, like, for the shortcut. When you cover equal distance in unequal intervals of time, for example, if this distance is also d, this is also d, you divide your total distance in equal distances, equal parts of distance, then the formula for average becomes 2 v1 v2, or I will just write the general formula so you don't get confused. The formula becomes 1 upon v is equal to v average is equal to 1 upon v1 plus 1 upon v2, and you can keep on adding as many terms, as many distances you have. Then the second was when you cover in equal intervals of time. If time intervals are equal, in that case the formula for average speed or average velocity is same as the average of any number, like the maths, the average formula which you use in maths, that is v1 plus v2 plus v3, or divided the total sum of terms divided by the number of terms. For example, you have n number of terms, then you divide it by n. Just need to remember these two formulas for average speed, right? So these were the basic things. Then the next concept which you studied was for acceleration. Acceleration, right? Acceleration was change in velocity per unit time. Then there were two concepts from the point of view of numericals you need to remember. First was the concept of instantaneous, and second was average. As we just saw, for average speed and average velocity, whenever you calculate average, for average you always have a defined interval. Interval means, like, that time interval is big enough. For average, because the time interval is big enough, you will always take the absolute change. You will always take a absolute change. Why you will take a absolute change? Because in that big interval, there will be a significant amount of change that can be actually seen by you. But on the other hand, for example, like, I'll just write the formula also for you people. So V average will be basically delta x by delta t. Why am I putting delta? Delta means absolute change. But whenever I'm talking about instantaneous, so in instantaneous, that means I'm saying at that particular instant of time. That means I'm saying within this 1 second, what is the change? So for instantaneous, when I'm talking about instantaneous, the time interval is quite small. Now, because the time interval is small, I cannot take the absolute change. Instead, what I have to use is I have to use differentiation and integration. For example, I need to calculate velocity. Velocity is differentiation of position with respect to time. That is dx by dt, right? And then the reverse of this also I can calculate if I want to calculate position from velocity. I am given velocity is a function of time and I want to calculate my position. So position is simply integration of v with respect to dt. You just need to take this dt over here, integrate on both sides, right? So I'll do this is the main difference between your instantaneous and average concept. Now what I'll do is I'll just discuss two simple questions based on two things. If you are given the position as a function of time, 3t square plus 2t, and you need to calculate the velocity at, let's suppose, t is equal to 1 second, and you need to calculate the acceleration at t is equal to 2 seconds. What will be your answer and how will you calculate? So for finding the velocity, velocity is simply differentiation of x with respect to time. We just simply differentiate it with respect to time, that is 6t plus 2. Now I am asked to calculate the velocity at 1 second, that is at t is equal to 1. I'll just put the value of t as 1. So I get 8 meter per second. This will be given to you that this is in meter or centimeter or whatever unit. Then for calculating the acceleration, I have to again differentiate velocity with respect to time. This comes out to be 6. Now time has just vanished in acceleration. This means your acceleration is constant in this particular case. That means it is not dependent on time. That means if you check the acceleration at 1 second, 2 second, 100 second to 500 second or at any instant of time, your acceleration will always be 6 meter per second square, right? The second type of question might be just reverse of this. I might give you that velocity is a function of time is given to be, again I'll take the same function, 3t square plus 2t, okay, meter per second, and then you have to calculate the position at t is equal to 1 second. Now what we have to do is we just have to do the opposite of this. X is basically equal to the integration of v with respect to dt. I am given the velocity, I just have to integrate it with respect to time. So integration becomes 3t square by t by 3 plus 2t square by 2. 2 gets cancelled with 2, 3 gets cancelled with 3. I get t cube plus t square. Then I need to calculate the position at t is equal to 1. I just need to put the value. So x comes out to be 2 when you put 1 in place of t. So these are the two basic type of questions which might be asked. Like you will, I'm very sure that you will get either one of these questions in your exam day after tomorrow, right? So this was about the differentiation, integration, the calculus part. Then moving forward, there was a discussion on equation of motion. So equation of motion, basically you studied 4 equations. 3 you have already studied like in your lower classes. First was v is equals to u plus at. Second equation was s is equal to ut plus half at square. Then third was v square is equal to u square plus 2as. Fourth was distance traveled in nth second. Now fourth equation is very, very, very important. Again, I am sure that you will get at least one question from this using this, like based on this equation, distance traveled in nth second. So distance traveled in nth second is basically u plus a by 2 to n minus 1. Now n is the value of nth second. That means you need to calculate the distance traveled in third second. Then the value of n will be 3. You just need to use the initial velocity, put in the acceleration, you will get the distance traveled in nth second. So these were the four equations of motion, and based on these four equations of motion, using these equations, you used to solve the questions for free fall. Free fall, basically anything or any particle when it is falling in just in presence of gravity. Gravity means on that particular particle only gravitational force will be acting, and that particle will face a acceleration equal to acceleration due to gravity, that is 9.8 meter per second square in the downwards direction. So free fall questions can be something like you throw a stone uh, upwards with some initial velocity. What could be the total time of flight of that stone? What will be the maximum height till which that particular stone will reach? For free fall type of questions, you just need to remember two things, two very important things. First of all, you just need to remember one thing, that at highest point your velocity will always be zero. The second important thing which you have to remember is like the way of solving the question, that is simply that you need to just identify the two positions, the two points between the whole trajectory, and you need to pick those, choose those 2 points wisely, and then put equation, any of these equations between those like within those 2 points, and then you will be able to solve the question. Okay. So for free fall, like 2 to 3 simple things are always asked. The total time of flight, the highest point till which or the maximum height till which the stone will go or the ball will go. Then the third thing could be the velocity with which it will hit the ground, or they might ask you to calculate the velocity or height at after some time. Like if I say, if a stone takes total, the time of flight comes out to be 4 seconds. Then I might ask you, like, now you have to remember the symmetry. So symmetry basically was that this is your line of symmetry. Anything which happens on the left hand side of this line, the same thing happens on the right hand side. That means if the total time of flight is 4 seconds, this means half of the time was taken to reach the top from the bottom, from the ground, and then the other half was taken from to reach the top to again the ground. So 2 seconds were taken to travel from ground to the highest point, then the later 2 seconds the particle returned from the highest point to the ground. Now I might ask you to calculate the velocity after 3 seconds. At 2 seconds the particle was at highest point, then at 3 seconds, after 3 seconds it have been somewhere in the middle, right? So for this 1 second, you need to, I might ask you to calculate the velocity, or I might ask you to calculate the height at which this particle was after 3 seconds, height above the ground. Okay, so these type of questions might be asked, right? So this was all about your free fall. And within this free fall, you also studied a law of Galileo's odd numbers, law of odd numbers. Law of odd numbers is it basically suggested that anything, any particle which is freely falling, it will always travel or it will always cover distances in the ratio of odd numbers. That is 1 is to 3 is to 5 is to 7 is to 9 and so on. Like the ratio of distances covered by that, by a freely falling particle in the successive in every 1 second, will always be a ratio of odd numbers. So this was Galileo's law of odd numbers, and that is all about our motion in a straight line. Moving forward to motion in a plane. Now motion in a chapter motion in a plane, the particle is basically motion in a plane. Particle is basically traveling in a plane. Plane means it is traveling, might be in xy plane, yz plane, or xz plane, right? So because the particle is traveling in a plane, now we have got the same equations, but we need to apply those equations two times. First in the x direction, second in the y direction. So like that was projectile. Before projectile, I am sure like you people now must be aware what is a vector, and within vectors you need to remember 2 to 3 things. What do you mean by position vector? What do you mean by displacement vector? Position vector, any vector starting from origin to a point that describes the position of that point. For example, I have a point, it has a coordinate x comma y, then the position vector of this point will be something like this, and I can write this vector as x I cap plus y j cap. X and y are my orthogonal unit vectors. Like, I am skipping the type of vectors part over here because I'm sure like that is a pretty basic thing which you people must be doing, right? So this is the position vector, and then displacement vector. If this particle comes from x1 comma y1 to x2 comma y2 point, then what will be the displacement and which vector will be representing this? So displacement vector, if the final point is x2 comma y2, then displacement vector is x2 minus x1 I cap plus y2 minus y1 j cap. This will be your displacement vector, right? Then a very basic question which usually comes like 70 or 80% of the times I've seen it in the exam, that you need to calculate a unit vector in the direction of a given vector. And most of the students commit a mistake. What you just need to remember is unit vector is any vector which has a magnitude 1. Now, unit vector, if you want to calculate in the direction of vector A, you just simply need to divide vector A by its magnitude. You will, whenever you divide a vector by its magnitude, you get a unit vector in that particular, in the direction of that particular vector, right? Then moving forward, there were 3 laws, but only one law was used to calculate the values. First was like for vector addition. First was your triangle law. Triangle law of vector addition suggested that if you have two vectors, you need to arrange them something like this, that the head of the first vector should be connected to the tail of second vector. You need to add both of these vectors, so the resultant of these two vectors after addition will be given by the third side of the triangle taken in the opposite order. That is what triangle law suggested. Then the second law was parallelogram law. In parallelogram law, we saw two formulas. So I'll just draw a simple diagram. This is your vector P. This is your vector Q. This is your vector P. You complete the parallelogram. Parallelogram law suggested if two vectors are represented, or if two adjacent sides of a parallelogram represent two vectors both in magnitude and direction, then their resultant will be given by the diagonal of this parallelogram. The magnitude of this resultant will be equal to root p square plus q square plus 2pq cos theta. The direction, like if the angle between p and q is theta, and the direction of this resultant, that is angle beta. So tan beta will be equal to simply q sin theta by p plus q cos theta. Even now, if you get confused that which should be the vector whose sine and cos component should be taken and which should be the other vector, just need to remember the vector with which this angle B is actually described with. So beta is basically the angle between resultant and P vector. So beta is the angle which resultant makes with the P vector. So you just need to remember the vector with which the angle is not described. The angle is not covered. You need to take both the components of this particular vector, for which vector the angle is not described. And the vector with which this angle is described, you just need to take the vector as a whole, right? So these were the two things which were used for vector addition. And mind it, these are the two most important formulas. You can't simply forget them. Then our third law was polygon law. Polygon law was basically an extension of triangle law to n number of vectors. Polygon law says that you can use any number of vectors, like you can add any number of vectors simultaneously. What does it suggest? That if all the vectors are represented in the same order by sides of a polygon, like they can be any number of vectors. For example, I need to add all these vectors. Then polygon law stated that the closing side of that polygon taken in the opposite order will give you the resultant of all these vectors, right? So this was your polygon law. The formulas were only given for parallelogram law. Within vector addition, you might also see vector subtraction. So in what changes occur in vector subtraction? Whenever you need to do vector subtraction, just change this plus sign to minus. This, don't change this plus sign, it remains as is. This plus changes with minus and this plus changes with minus. These are the two basic changes which occur when you move from vector addition to vector subtraction. This was the first half of the chapter. Like this was a one half. Then the other half of this chapter was projectile motion. Within projectile, you had 2 to 3 variations. So first was a very simple case, a simple oblique projectile. You're throwing it with some initial velocity u at an angle theta. First was your oblique projectile. Within oblique projectile, you were supposed to calculate 3 things, like the total time of flight. Total time of flight formula was 2u sin theta by g, the maximum height and the range. Formula for maximum height was u square sin square theta by 2g. Formula for range was u square sin 2 theta by g. And then there was something called as maximum range. Maximum range is equal to u square by g, and maximum range will only and only occur at angle of 45 degrees when theta is 45 degree. If you are asked to calculate the maximum height, vertical height, so maximum vertical height will be covered when you just simply throw it like a stone thrown in a upwards direction. That means angle should be 90 for maximum height. Okay, these were the 3-4 formulas. And the most important thing was the equation of trajectory, which most of the students ignore, but just remember it, it is quite important. So equation of trajectory was y is equal to x tan theta minus half g x square upon u square cos square theta. So many a times what they do is they just simply tell you that the equation of trajectory of a oblique projectile is y is equal to root 3x minus not half minus 4x squared, let's suppose. And then they ask you, to calculate theta and u. You're just given this equation of trajectory, you are asked to calculate both these things. It is a simplest question. Like I would say these are free marks for you guys. What you need to do is you just need to compare it with the general equation. So if you compare, the coefficient of x is tan theta, that means tan theta is equal to root 3. Value of tan is root 3 at an angle of 60 degree. So theta comes out to be 60. Then coefficient of x square minus x square is 4 over here, and the coefficient of x square is half g in your general equation, half g upon u square cos square theta. And over here this coefficient is 4, just equate it with 4, put the value of g is 10, 10 gets cancelled with 2, so 5 remains. Cos 60 value is 1 by 2, and 1 by 2 square 1 by 4, 1 by 4 goes above. So this becomes 5 into 4 upon u square is equal to 4. 4 gets cancelled with 4 and u square comes out to be 5. That means initial velocity with which projectile was thrown was root 5. Simple question, pretty simple. Okay. So this was oblique projectile. Then the second type of projectile was horizontal projectile. Horizontal projectile. Horizontal projectile, it basically means you're standing above at a height of tower h, at a tower of height h, and you are throwing a projectile horizontally, and then it comes down like this. You need to calculate 2 things, or rather I would say 3 things: time of flight, this range which this projectile covers, and the velocity. So you are throwing it horizontally with the initial velocity u, and the velocity with which it will hit the ground. So time of flight comes out to be 2u sine theta, sorry, not 2u sine theta by g. This comes out to be 2u by g. This comes out to be, or I would like first write the equation of trajectory. Trajectory becomes y is equal to minus half g upon half g upon u square x square. You just need to remember that when you come to horizontal projectile, your u cos theta in this case becomes u and your u sin theta becomes 0 because your initial velocity is just in the horizontal direction. The vertical component of initial velocity is 0. Just need to replace these two things in all the formulas of oblique projectile. So time of flight comes out to be root 2h by g. Range is u multiplied by root 2h by g. That means u multiplied by time of flight. And the final velocity with which hits the ground, or I would say after time t, if I need to find out the velocity. So this comes out to be your u square plus gt whole square. And this is the velocity at any time small t. If you need to calculate the velocity with which it will hit the ground, then that formula will come out to be v is equal to root u square plus 2gh. This is the velocity with which it hits the ground. This is the velocity after time t. Okay. So this is horizontal projectile. And then you also might get a question that you are standing on a tower and you are throwing a projectile upwards, so it falls like this. You need to calculate the time of flight. The process is same, everything is same. You just need to apply the equations. Then there was circular motion. Within circular motion, you have uniform as well as non-uniform circular motion both in your syllabus. For circular motion, the very first thing was you just need to remember one table. As we have x or position in linear motion, we have theta or angle in circular motion. As we have velocity v in linear motion, we have angular velocity omega in circular. We have acceleration a, over here we have acceleration alpha. Theta is simply representing the position or the angular displacement. Omega is angular velocity and alpha is angular acceleration. If I tell you the relation, so theta is basically delta s by r or delta x by r using the formula of arc upon radius. Then omega is basically delta theta by delta t. In a very similar way as we say v is equal to delta x by delta t. Right? Then we have alpha is equal to delta omega by delta t. And your A is delta V by delta t. Right? So these were the formulas. Now you need to remember two things. First, the relation between frequency and time period, it is 1 upon time period. Then if you need to relate angular velocity with time period, it is basically 2 pi by t. How does this formula come? Omega is equal to 2 pi by t. You use this formula within one time period. Like time period is the time taken to complete one revolution or one rotation. If you complete one rotation, your total angle prescribed is 360 degrees. That is 2 pi radian divided by time is capital T. That is equal to time period. So omega is equal to 2 pi by t is the formula which you need to remember. And then 1 upon t is frequency. So 2 pi nu also you can write. Then coming to the relation between these two particular things like linear and circular motion, how can we connect both these things? So first formula is v is equal to r omega. That means linear velocity is equal to radius multiplied by angular velocity. If I like talk about the vector formula, because all these things are vectors, so v is equal to r cross omega. Okay, v is equal to r cross omega. Then relation between a and alpha, a is equal to alpha cross r. Cross is basically the cross and dot product. So like I believe you must know cross and dot product, so will not like spend too much time on that, right? So these are the relations. Then the last thing was centripetal acceleration. centripetal acceleration. Okay. The formula was centripetal acceleration or centripetal forces. F is equal to mv square by r. This is your centripetal force. And then your formula for centripetal acceleration is v square by r. V square by r. And now you can, create 2 to 3 versions of this formula. Like you can substitute v in terms of r and omega. So one formula you can get r omega square. Then you can also like bring in frequency. So 4 pi square nu square r. Then you can also write it as 4 pi square r upon t square if you need to bring in time period. So this was centripetal acceleration. Okay. So this is our end of kinematics. That is motion in straight line and motion in a plane. Moving forward to our next chapter. Next chapter is laws of motion. Laws of motion, you basically know the first law. First law is basically law of inertia. Like I mean, law of inertia and first law are slightly different, but they mean the same thing only. So first law states that any body will remain in motion until and unless an external force is applied on that body. Law of inertia states that if a body, like law of inertia states that every body resists the change in its state of motion. There were 3 types of inertia: inertia of motion, inertia of rest, inertia of direction. Then the measure of inertia was basically mass. Greater the mass of a body, greater is its inertia. That means a heavier body will have a greater resistance to change in motion, change in its state, and a lighter body will have a relatively lesser resistance to change in its state of motion. So first law states that every body will continue to be in its state of rest or of motion in a straight line unless and until external forces applied on that body to change the state. That was basically the first law connected with inertia. Second law states that the rate of change of momentum, that is dp by dt, rate of change of momentum of a body is directly proportional to the force. From here we got a formula. Like if you put in place of momentum you substitute m into v, so you will get a formula: F is equals to m into a, right? So this was the second law, and the third law was action and reaction law, that every action has an equal and opposite reaction. Action and reaction law. Now over here only you study 2 to 3 like basic quantities. First quantity was momentum. Momentum was basically symbol is p, formula is m into v. M is a scalar quantity. Direction of momentum is same as direction of velocity v. So this is momentum. Then for momentum you can see 2 graphs, that if mass is constant, momentum will be directly proportional to velocity. Velocity is constant, momentum is directly proportional to mass. But if momentum is constant, if p is constant, in this particular case your mass is inversely proportional to velocity. That means a heavier body will have a lesser velocity, a lighter body will have a greater velocity, right? So this was one quantity. Then the second quantity was impulse. Impulse or impulsive forces, as you must have heard, is that the force which acts for a very short period of time, a very short period of time. A force which acts for very short period of time is basically impulse, and impulse, the symbol is J. Impulse can be calculated by F multiplied by delta T, F dt. Impulse is also a vector quantity, and the direction of impulse is same as direction of force. Then there was a theorem, theorem or law, you can say impulse momentum theorem. Impulse momentum theorem states that impulse will always be equal to the change in momentum. Delta P is equal to J is equal to F delta T. So this was impulse momentum theorem. Then you might also be asked to calculate the impulse from force time graph. So if you have a force time graph and you need to calculate impulse, then what you have to do is you just need to find area under this graph. Area under FT graph, area under force time graph will give you impulse. Then there were some applications of impulse. For example, like whenever you fall on sand, we get hurt less, but falling on a cemented floor will actually cause you a uh, I would say a very bad injury, because in cemented, when you fall on a cemented floor, you don't get a time to change your momentum. That change occurs in a very small period of time, so a very greater force acts on you. In case of sand, the sand gets some like sand gives you some time to change your momentum. So because that occurs in a greater period of time, so the force acting on that particle is less. So that is impulse momentum theorem. Then the third law of motion was action reaction. Every action has an equal and opposite reaction, but the net force acting on the system is not zero. Net force acting on any particle is not zero. Why? Action and reaction both acts on two different bodies. So for action reaction, like you can just simply say a basic example could be a particle is kept on a table. Weight of the particle acts downwards, and then this table exerts an equal and opposite reaction force in the above direction. And action and reaction are always equal in magnitude and opposite in direction, right? Moving forward, then we had connected motion. Connected motion was basically mass pulley system. So you have got a pulley just like this, mass m1 over here, mass m2 over here, and you say if the mass of m1 is greater than mass of m2, there is tension in the string and this system will move like this. You need to find out tension in the string and the acceleration. So tension, the formula was basically 2m1 m2 upon m1 plus m2 into g, and for acceleration your formula was m1 minus m2 by m1 plus m2 into g. So this was the formula for tension and acceleration, tension in the wire and acceleration of the system. Then there was apparent weight of a person in a lift. So for lift, we had 6 cases. In the first 2 cases, the answer was same. Like for the first case, when a lift is at rest, your apparent weight is your actual weight. Second case, when elevator is moving with a constant velocity, that means zero acceleration. So I'll just take it like, okay, I'll write it over here, elevator or lift. First case, if you are at rest, the elevator is rest, apparent weight is equal to actual weight, right? Second case is same, velocity is constant, acceleration is zero. So your apparent weight, like the same equation, apparent weight is equal to actual weight. Then in third case, if the elevator is moving vertically upwards with acceleration a, your weight is apparent weight is more, weight is increased than actual weight, and your effective g effective becomes g plus a. Your acceleration of the elevator also gets added to the acceleration due to gravity. And when elevator moves in a downwards direction, it just becomes opposite case, it becomes g minus a. These were the four like main cases. Then in the fifth case, we consider if the elevator falls freely, that is with the acceleration, with the acceleration equal to g, acceleration due to gravity, your apparent weight becomes zero, you feel weightlessness. Sixth case, if the elevator falls with the acceleration greater than acceleration due to gravity, your apparent weight becomes negative. Your apparent weight becomes negative, so the person will stick to the wall. Like you will stick to the wall of the elevator or the lift. Then there was law of conservation of linear momentum. So law of conservation of linear momentum basically stated, if no external force is acting on a system, then the linear momentum of the system will be conserved. That means the total initial momentum will be equal to the total final momentum. The equation will be So u1 was the initial velocity of first particle, u2 initial velocity of second particle, v1 and v2 final velocities of m1 and m2. Total initial momentum is equal to total final momentum. Now, based on conservation of momentum, you can get some application based questions, like you can be asked to find out the recoiling velocity of gun. So initially gun and bullet both are at rest, then you will be given the velocity with which bullet will leave the gun, then you need to calculate the recoiling velocity of gun. Or like the most common question is on the bomb thing, like a bomb is blasted into 2 or 3 pieces. First piece goes in this direction with this particular velocity, second goes in this, and then you have to calculate the velocity of the third part of the bomb. All these questions are based on your conservation of moment, linear momentum. Then there was something called as concurrent forces. So the forces acting on a single point, and the vector sum of these forces should be 0, then they will be called concurrent forces. All the forces acting on a single particle whose vector sum is 0, that is called concurrent forces. So for concurrent forces, after concurrent forces, there was something called as FBD. Free body diagram. Free body diagram basically suggested that whenever you are given anything, for example, I have this sort of a mass pulley system. You just need to, in a free body diagram, you just need to make all the forces which are acting on this particle. So there will be some tension T in the string, there will be some tension T, there will be weight m1g in the downwards direction, there will be a normal reaction. So what you need to do, you need to make the FBD, that is free body diagram of all the particles, and then you need to apply the equations. So m1 will go in this direction, so T will be equal to m1a and R will be equal to m1g, because there is no motion in the vertical direction. In vertical direction, particle is in equilibrium, so vertical forces are equal, but along the horizontal there is a net motion. What you need to do is you need to calculate the net force and equate that net force with mass multiplied by acceleration. Simply net force is equal to mass into acceleration. So there are 2 to 3 steps for solving the numerical problems using FBD. What you need to do is, in the very first step, you need to draw a very neat and clean labeled diagram. Second, you need to consider that object or a body as a point source, and then you need to mark the different points, like m1 is this point, m2 is this point. These are 2 different particles. In the third part, you need to make the FBDs of all the objects involved in the system or in the picture, and then in the last part you need to draw all the forces acting on those particles and write the equations using equilibrium and motion condition. If particle is in equilibrium, all the forces acting in opposite direction will be equal, they will cancel out each other. If particle is moving, then net force will be equal to mass multiplied by acceleration. Just need to remember these 2 to 3 things. Then there was friction. So in friction, you had studied 3 types of friction: static, limiting, and kinetic friction. Static friction is a self-adjusting force. Static friction is like it is applied in the same amount as the applied force. That value keeps on increasing. So for friction, you saw a graph was something like this, graph between applied force and frictional force. So friction was on y-axis and applied force was on x-axis. Till here we have static friction. The value of static friction keeps on increasing till a point. Then this becomes maximum. This is maximum value. Maximum value of static friction is limiting friction. Then this value reduces and then settles to a constant value. This is kinetic friction. Kinetic friction acts when the particle is actually moving. Static friction acts when the particle is at rest. Limiting friction acts when the particle is just starts to move, right? And all the forces, that is like the frictional forces calculated by mu Sn, or normal reaction multiplied by coefficient of friction. This is always equal to frictional force. Then in case of circular motion, we had 2 to 3 things. So the very first thing is your Centripetal force we have already discussed. Centripetal force formula is mv square by r or mr omega square. And within circular motion, we had three applications. First was bending of cyclist. Bending of cyclist. So at what angle should the cyclist bend? Safe angle. So for bending of cyclist, the formula was tan theta is equal to v square by rg. Then second was your banking of road or circular motion of a car on first level road. In case of level road, your safe velocity will come out to be like the maximum velocity will be root mu rg. And then in case of a banked road, your formula was v is equal to under root r into g mu plus tan theta divided by 1 minus mu tan theta. Right? Rg in under root we take Rg into mu plus tan theta by 1 minus mu tan theta. Banking of road is more important as compared to the bending of cyclist and banked road. Banked road, like on this question will be 100% asked. Bending of a cyclist comes sometimes, sometimes it is not asked. Then the fourth and the last thing was vertical circle. In case of a vertical circle, you just need to remember 2 to 3 things. What 2 to 3 things you need to remember? You need to put a particle in a vertical circle. This is your starting point. At the lowest point, you just need to find two things, the velocity at that point and the tension in the string. So this is a string, tension will act like this. This is when 1/4 of a circle is covered, that is midpoint when you reach half height, and this is the highest point. Over here at the lowest point, minimum velocity is root 5gr to put the particle in a vertical circle. If the velocity is less than this root 5gr, the particle will not complete a vertical circle. Tension at this point will be greater than equal to 6 mg. Minimum tension will be 6 mg. At midpoint m, the velocity was greater than equal to root 3gr. Tension will become greater than equal to 3 mg. Then at highest point, velocity was greater than equal to root gr and tension was greater than equal to 0. Like, why am I writing greater than equal to? These are the minimum values. So this was all about the vertical circle, and this brings us to the end of laws of motion. Then moving forward to our next chapter, that is work, energy and power. Now starting from this chapter, we'll discuss all the formulas. So work is basically a scalar quantity, and work can be calculated as a dot product of force with displacement, F dot S or Fs cos theta. Theta is the angle between force and displacement vector. Unit of work is joule, right? And you already know that if you're given the vector of the force vector and the displacement vector, then you can calculate work using dot product. Now work can be positive, negative and 0. Negative when angle is 180 degree, positive when angle is acute between 0 to 90, 0. Work done will be 0 when theta is 90. Then work done can also be calculated by area of graph. Like if you are given a force versus displacement graph, then area under force displacement graph, Fs graph, will give you work done. Now work is always done by a force. Now forces can be of two types, conservative and non-conservative. Conservative forces, the forces for the work done by which force is independent of the path followed. That means if you need to reach from A to B and you have got, let's suppose, these 4 paths, right? Then work done by the conservative force to reach from point A to B will not depend on the path you have chosen. It will just depend on the initial and final points. So an example of conservative force could be gravitational force. But for a non-conservative force, the path will matter. For example, it might be the case if you chose first path, then the work done by non-conservative force on this path can be more or less as compared to the second path. So non-conservative force you need to remember. One example at least you should know, that is friction. Frictional force is non-conservative. Frictional, the value of frictional force actually depends on the path followed. Why does that? Now the reason being, why is frictional force a non-conservative force? Because friction will depend on the surface, the interlocking and the irregularities of the surface. So friction is part dependent and not only initial and final point dependent. Then moving forward to energy. So work and energy are one and the same thing. Energy, so work is stored in any object or in any body in the form of energy. Energy can basically be described as the capability or capacity for doing work. Formula is same. Now energy can be of three types, or mainly two types: kinetic energy and potential energy. Potential energy can be of further two types. Kinetic energy formula is half mv square. Kinetic energy is possessed by the object due to virtue of its motion, right? Now, potential energy comes due to the virtue of change in state, like gravitational potential energy whenever an object goes to some height, that is mgh. And then there was your the potential energy, that is elastic potential energy, which is in the spring. Elastic potential energy formula is basically half kx square due to change in orientation. Now there was a theorem called work energy theorem. So work energy theorem basically states that work done by any object will always be equal to the change in kinetic energy. Total work done will always be equal to the change in kinetic energy. Then kinetic energy and potential energy. Potential energy is of two types. First is possessed by any normal object. This elastic potential energy is usually seen in a spring. So for spring, you should also remember the restoring force. Restoring force is equal to minus kx. Minus sign because it is restoring, right? Then you also should remember, like, I'll just make sure to cover as many graphs as possible because graph is one of the most favorite things for NEET exam, right? The graph for potential energy and position of a spring. This graph is a parabola. So this is your maximum point. So this side is for compression, this side is for extension, and the potential energy will vary something like this. Formula will be half kx square in case of a spring. Now k is your spring constant. K can be calculated by spring constant can be calculated by restoring force per unit displacement, F divided by x. Then there was law of conservation of energy. So total energy of a body is always conserved. The total mechanical energy is simply equal to the kinetic energy plus potential energy. Total mechanical energy is always conserved. Then there was a second thing, which was simple pendulum. In case of simple pendulum, energy is conserved. Now you need to remember the graph for simple pendulum. For simple pendulum, there are three graphs. This is the graph for mechanical energy. This remains conserved. We have U versus X. Then the graph of kinetic and potential energy. Potential energy graphs look something like this. I will just draw it properly. This is for potential energy. And let's use yellow color. This graph in yellow color over here, this is for kinetic energy. Now, what does these graphs tell you? Pendulum is something like this. Okay, so like what we can do is, for simplicity and to avoid confusion, I'll just draw the pendulum over here. Corresponding to graph, you need to check it out. Okay, so how is this pendulum moving? So this is your mean position. It has some velocity over here at this particular point, lowest height. It goes here, comes back, then moves to the opposite side. These are the two extreme positions, and this is your mean position. Now at the mean position, it only has some velocity. So at the mean position, all the energy, the total mechanical energy is just in the form of kinetic energy. Potential energy is zero. At the extreme position, it reaches some height h, the velocity becomes zero, and it starts to move in the opposite direction. So at extreme position, only potential energy is there. So total mechanical energy is equal to potential. Kinetic energy is zero at extreme positions because velocity becomes zero. So you just need to remember this graph for your simple pendulum, and you can also, just remember one simple formula. Velocity at mean position should be equal to root 2gh. Like it can calculate it by this. So h is the height, the maximum height till which the pendulum bomb will go. The law of conservation of energy states that total energy will always remains conserved. So this whole thing is basically based on law of conservation of energy. Then we come to collision. So collision, there were three types of collision: perfectly elastic, inelastic, and perfectly inelastic. Perfectly elastic, both linear momentum and energy remains conserved. Inelastic, linear momentum remains conserved, but kinetic energy doesn't remain conserved. Perfectly inelastic, basically, whenever two objects collide, they just stick together and move as a single object. That is perfectly inelastic. So, moving forward, then you have two things over here. First was elastic collision in 1D. So, for elastic collision in 1D, we had two formulas. So, first formula was, like, the meanings have the symbols are usual in meaning: m1, m2 masses, u1, u2 initial velocities, v1, v2 final velocity. v1 formula was m1 minus m2 upon m1 plus m2 into u1 plus 2 m2 u2 by m1 plus m2. You just need to remember the formula for v1. To find out the formula for v2, you just need to swap the subscripts, that wherever 1 is written, change it with 2, replace 2 with 1 and 1 with 2. Just that. That would work. Okay. So this is the formula for V1 and V2 in elastic collision in 1D. Then elastic collision in 2D, we can't actually find out the formulas because the number of unknowns are more. So in the question, either you will be given some things. You just need to use two concepts. First, conservation of linear momentum. Second, conservation of kinetic energy. Both these things will do. So over here for elastic collision, once we conserve linear momentum, once we conserve kinetic energy, we have two unknowns V1 and V2, two equations to calculate them, right? Then we had inelastic collision in 1D. For inelastic collision in 1D, we need to find out the final velocity. Inelastic, both the objects stick together and move as a single object. So formula is m1 u1 by m1 plus m2. The second particle was at rest. The first particle came, collided with the second particle. Both particles get stick and move with the same velocity as a single particle. So that was inelastic collision. Okay. Then moving forward to rotational motion. Rotational motion. So rotational motion, the very first thing which you need to remember is, what do we mean by moment of inertia? What do we mean by center of mass? So we will just start by discussing moment of inertia. So moment of inertia formula was I is equal to summation m r square, or the general formula is simply m r square. And then there were two theorems, theorem of parallel axis and perpendicular axis. Moment of inertia you need to remember for some objects, like for some regular shaped bodies. In case you don't know, then you can just write it down simultaneously. Along the center of mass for a rod, I'll just draw the diagram. For a rod, axis passing through its center moment of inertia is ml square by 12, and along, sorry, not along this axis, ml square by 12. If the axis is over there, then about this axis it's ml square by 3 for a simple rod. For a ring, formula is mr square and mr square by 2. Like, this is a ring, along the center mr square, and along the diameter, like this, center is this axis. So along the center mr square, along the diameter mr square by 2. Then whenever you move from ring to disk, everything becomes half. For ring, formula was where rotation inertia is mr square. Along the same axis for a disk is mr square by 2. For a ring, along the diameter was mr square by 2. For a disk is mr square by 4. Then for solid sphere along the diameter, solid sphere is one of the most important object. Like, it is used at many places. 2 by 5 mr square for solid sphere. This is MOI, moment of inertia. Then radius of gyration, the formula for radius of gyration was simply root L upon M, right? And then you studied two quantities. First was angular momentum. Angular momentum was basically R cross P, or I can say in terms of scalar formula MVR, or I into omega. I'm writing the scalar formulas as well. Then the second vector quantity which you studied was torque. Torque was simply R cross F, or your I into alpha, if I talk about torque in a rotational motion. Then, as we studied the equations, the three equations of motion in linear motion, you can also similarly write three equations for rotational motion. Omega naught is the initial final velocity. Sorry, not omega naught. We'll just use omega 2 and omega 1. Omega 2 final velocity, omega 1 initial velocity, plus alpha is the acceleration and t is the time. Then second equation was s is equal to ut plus half at square. Instead of s write theta. Omega 1 into t plus half alpha t square. Then omega 2 square is equal to omega 1 square plus 2 alpha theta. These are the three equations of motion for rotational motion. Then there was something called center of mass. It is a point at which whole mass of the body is supposed to be concentrated. Then you need to find out the center of mass for some particular object. So you should remember those. Center of mass, COM. Okay, moving forward to gravitation. In gravitation, you just have some, like, comparatively less number of formulas. So for gravitation, there were three Kepler's laws of planetary motion: law of orbit, law of area, and law of periods. Okay, law of orbits says that every particle, every planet revolves in a fixed orbit around the sun. Law of area suggests that the area described by any planet when it is moving in orbit is always constant. Then law of period suggests that the square of time period is directly proportional to cube of your length, right? Distance covered. Then after this, there was universal law of gravitation, that is F is equal to, formula was G m1 m2 by r square. G is your universal gravitation constant, value is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. Then characteristics of gravitational force, there were primarily four characteristics. It is weakest force, central force, always act along the centers, always attractive in nature, it will never be repulsive, and then applicable on all objects, irrespective of their shape and size. Then there was a discussion of acceleration due to gravity and how does it vary. Acceleration due to gravity, the formula will be gm upon r square, mass of earth, radius of earth. And how does the acceleration due to gravity vary? So we saw three variations mainly. First with height. So with height, the formula becomes G into 1 minus 2h by R. With depth, the formula becomes 1 minus d by R. And the third was the variation with rotation or latitude. The variation with rotation or latitude. So the formula over here was G dash is equal to G minus R omega square, R omega square cos square lambda. And then using the last formula, that is for latitude, we saw two things, that at poles the value of G is maximum, that is acceleration due to gravity is maximum at poles, and at equator it is minimum. This was about acceleration due to gravity. Then there were two things, gravitational field and gravitational potential. So gravitational field was basically, formula was G m by R square, gravitational field. This was field, and then gravitational potential was V, if I say, minus Gm by R, that is work done basically. Then gravitational potential energy was minus Gmm by R. Now, why is there a minus sign in all these formulas? So, as soon till the time energy is negative, your particle is bounded to Earth. As soon as this energy becomes, the maximum value can be zero, it can never be positive. As soon as the energy of any particle becomes zero, it will like go out, or it will just escape the attractive force of Earth. It will be free to move in that particular case. So gravitational field, gravitational potential, and gravitational potential energy. Then the last thing from where mostly questions comes was basically the satellites or the orbits part. So escape velocity, the formula of escape velocity was root 2 g m by R, and this value comes out to be 11.2 kilometer per hour. That means escape velocity was basically that velocity with which you have to throw some particle to so that in order to make it escape the Earth's gravitational field. If you throw this, sorry, it is not kilometer per hour, it is kilometer per second. Kilometer per second, 11.2. Then orbital speed or orbital velocity with which the satellite will revolve in the orbit. Orbital velocity was escape velocity divided by root 2. And finally, we had the total energy of a satellite. It is potential energy plus kinetic energy. Kinetic potential energy is G minus G m m by R. Kinetic energy is G m m by 2R. Total energy is minus half G m m by R. Okay. So these were all the formulas for gravitation chapter. Just remember that like over here we are just doing a quick revision for your exam. Like I can't teach you all the concepts from scratch in this class because this is supposed to be a revision marathon and we have to cover all the chapters. Moving forward to chapter mechanical properties of solids. So mechanical properties of solids, you basically studied stress and strain. Stress is basically pressure, force acting per unit area. Strain is change in configuration divided by the original configuration. Then there can be three types of stress and three types of strain. So three types of stress, if there is a change in length or only a single dimension, that was called longitudinal stress. Sorry. Longitudinal stress. Longitudinal stress was simply F upon A, force acting per unit area. Corresponding to this, we had longitudinal strain. Longitudinal strain was delta L by L. Then we had volumetric stress, or before volumetric, I'll go by order. Shearing stress. Shearing stress means in which shearing, or it is also called tangential stress, in which area is changed. This was basically force upon area, and corresponding to this we had shearing strain. So shearing strain was basically your change in the angle. And after shearing strain we had volumetric stress. Volumetric stress was again F upon A, and it is basically change in volume. Okay. So these were the three types of stress and corresponding to those three types of strain. Then there were modulus of elasticity. So modulus of elasticity is basically stress divided by strain. Modulus of elasticity, like Young's modulus or bulk modulus, it is basically stress divided by strain. Young's modulus, longitudinal stress by longitudinal strain. Longitudinal strain is delta L by L. Young's modulus corresponding to this is mg delta L by pi r square L. Then corresponding to shearing stress or shearing strain, we had modulus of rigidity, or like first I can write the formula for shearing strain. Shearing strain was basically equal to a angle theta. Formula was eta. For modulus of rigidity, formula is F upon A theta. Then last we had volumetric stress or volumetric strain, F by A. Volumetric strain is basically delta V by V, minus delta V by V, because the volume always decreases due to strain. Modulus of elasticity was beta, that is bulk modulus. Formula for beta is minus delta P by delta V by V, right? Change in pressure divided by change in volume divided by original volume. These were three types of stress, three types of strain. Corresponding to these three types of stress and three types of strain, we had three types of modulus of elasticity. Young's modulus, modulus of rigidity, and bulk modulus. And lastly, we had elastic potential energy and Hooke's law. Hooke's law basically stated that your stress is directly proportional to strain. This was stated by Hooke's law. And the formula for elastic potential energy in a stretched wire, elastic potential energy was basically half into stress into strain into volume. Half stress into strain is basically energy stored per unit volume. If you multiply it by volume, you will get the total energy. Total elastic potential energy in a stretched wire. So solids was a relatively like a small chapter. Then the next chapter was mechanical property of fluids. Within fluids, you had Pascal's law, Torricelli's law, then some application of Pascal's law, right? So fluids, first of all, you can say that the flow of fluids can be streamlined or turbulent. Streamlined when the velocity is less than the critical velocity, turbulent when it is greater than the critical velocity. Critical velocity is a sort of a fixed value, right? And then we had equation of quantity, Pascal's law. Pascal's law basically stated that the pressure exerted at any point will be transmitted equally in all directions. So the very first thing which we had is I'll keep on writing I'll start with the formula. So first formula was for surface tension. Surface tension was basically force acting per unit length. Surface tension. Corresponding to surface tension, you had surface energy. Surface energy was basically work done per unit area. Surface tension, surface energy. Third was the height to which a liquid will rise in a capillary tube. That capillary rise or fall was H is equal to 2s cos theta divided by r rho g. R is the radius of capillary tube, rho is the density of liquid, and g is the acceleration due to gravity. Then there were two formulas for excess pressure. Excess pressure inside a liquid drop, if we say a normal liquid drop, excess pressure was 2s by r. If we say a soap bubble, for soap bubble, this excess pressure was just doubled, 4s by r. The reason why there is a multiplication factor of 2 when you move from liquid to a soap bubble is that a soap bubble has two free surfaces while a liquid has only a single free surface. So it becomes double because there are two surfaces, 2s by r acting on this, 2s by r acting on this, total becomes 4 times, 4s by r. Then there was something called atmospheric pressure, and how you can calculate pressure. So pressure is basically thrust upon area or force upon area. Thrust upon area or force upon area. Pressure exerted by a liquid column formula was rho g h, yeah, rho h g. Pressure exerted by a liquid column at a height or a liquid column of height h. Then there was something called atmospheric pressure. The value of atmospheric pressure is fixed. That is your 1 atmospheric pressure, 1 atm, or you can convert this 1 atm to other units, that is your pascal or mm of hg, atmospheric pressure. Okay, so I will just remove this atmospheric pressure. This is just a constant value. Moving forward, then the next thing we had, the very next thing which we had was, we'll take it on the other slide, that is equation of continuity. Equation of continuity. Equation of continuity basically stated that your total area A1 V1 rho 1 will be equal to A2 V2, or A1 V1 is equal to A2 V2. This is a pipe. A fluid is flowing from this end to the second end. The area over here is A1, the velocity over here is V1, the area over here is A2, velocity is V2. The total product of area with velocity will always be a constant. That is was about equation of continuity stated. And based on equation of continuity, you can also derive the formula for liquid, the height till which the velocity of efflux. Basically, water is filled in this beaker. What is the velocity of efflux if the water will come out from here? So velocity of efflux is basically equal to root 2g h. H is the height at which you just poked a hole in the liquid column. Then the most important thing was Bernoulli's principle. Bernoulli's principle basically stated that the sum of total energy per unit volume will always be a constant. That is pressure head plus kinetic head plus rho gh, gravitational potential head. These three, the sum of these three things will always be a constant. This was Bernoulli's theorem, and then we had Stokes' law. Stokes' law, force, the formula was force is equal to 6 pi eta r v. The force acting on a particle is equal to 6 pi multiplied by eta is the coefficient of viscosity, r is the radius of the ball, v is the velocity with which it is falling. So this brings us to the end of our mechanical properties of fluids. Now for today, what we can do is we can spend just 10 more minutes. I know it has been a lot for you people. We have revised almost everything, only thermal properties of matter, thermodynamics, and oscillations and waves. 4 chapters are left. So what we'll do is we'll just revise the formulas quickly. Like for thermal properties, what all formulas you had for thermal properties? For thermal properties, if you see, you had some basic formulas. First thing being your this specific heat, latent heat, thermal stress, and type of thermal expansion which can actually happen in a solid, right? Linear expansion when only the length increases or length changes, aerial expansion or area expansion or superficial expansion when area changes, volume or cubical expansion when the volume changes. So for linear expansion, we had coefficient of linear expansion alpha, which was equal to delta L by L naught delta T. L naught is the original length, delta is the change in length, delta T is the change in temperature. This was coefficient of linear expansion. Then superficial or area expansion, delta A by A delta T. Then volumetric expansion was the last, and the coefficient was gamma. Delta V by V naught delta T. The relation between these three coefficients was gamma is equal to 2 beta is equal to 3 alpha. Basically, if you take the ratio of alpha is to beta is to gamma, alpha is to beta is to gamma, this ratio will come out to be 1 is to 2 is to 3. Okay, 1 is to 2 is to 3. This will come out to be the ratio. Then thermal expansion, basically expansion, whenever thermal expansion happens, a thermal stress develops. This was the first part. Then the second part was specific heat. So specific heat capacity is basically Q divided by M delta L. Q is the total heat, M is the mass, delta L is the, sorry, delta, not delta L, delta T. Delta T is the change in temperature. Then heat capacity, this is specific heat capacity, and heat capacity is basically delta Q by delta T. Then the last thing was molar specific heat capacity, which was small c. This is capital C, specific heat capacity. Molar specific heat capacity, small c, is basically this capacity divided by N. So you just add delta Q divided by N delta T. Right? And in the end, you add Stephen Boltzmann law, and wherein Boltzmann constant, Newton's law of cooling, and Wien's displacement. So I think like those are comparatively less important part of this chapter. Moving to thermodynamics, a lot of thermodynamics part has been, just removed simply. So for thermodynamics, you just need to remember the three laws. Zeroth law of thermodynamics. For zeroth law, it basically states if two systems are in equilibrium with the third system, then these two systems will always be equilibrium with each other. Then the first law of thermodynamics. Zeroth law, then first law. First law basically states that delta Q is equal to delta U plus W. That means your total energy or total heat will be equal to change in internal energy plus the work done. And work done can be calculated by P delta V, pressure multiplied by change in volume. And then second law. Second law was basically based on the engine. It basically stated that it is impossible for an engine working between a cyclic process to extract a heat from a reservoir and convert completely into work. That was second law, right? And then you need to just calculate the formula, like just remember the four types of processes. So there were four types of processes: isothermal, isochoric, isobaric, and adiabatic. Isothermal, temperature remains constant. I'm just writing in the bracket the quantity which remains constant. Isochoric, volume remains constant. Isobaric, pressure remains constant. Adiabatic, heat remains constant. The general equation basically for isothermal, PV will be a constant. PV is a constant, so work done in an isothermal process can be calculated by V1 to V2 nRT upon V dV. Then isochoric, P by T is a constant, pressure upon time is a pressure upon temperature is a constant. P1 by T1 is equal to P2 by T2. Then isobaric, V upon T is a constant. And lastly, adiabatic equation was PV raised to the power gamma is a constant. Gamma is the degrees of freedom. Lastly, you had ideal gas equation. So ideal gas equation was basically PV is equal to nRT. PV is equals to nRT. That was your ideal gas equation. And the last thing which we'll do today is like just remembering the work done, the formula for work done for all these processes. So work done, it can be calculated by area under PV graph. Work done, the formula is P into delta V. For thermodynamic processes, we'll just start with your isothermal process. For isothermal. For isothermal, in which temperature is constant, your work will be 2.303 nRT log V2 by V1. Or you can also say 2.303 nRT log P1 by P2. Second, in adiabatic process, work done will be 1 upon gamma minus 1 nRT1 minus nRT2. This is work done in adiabatic process. You can just take nR outside the bracket as common. Then isochoric, work done is P delta V. Delta V is 0. Since delta V is 0, in isochoric volume remains constant. So work done is 0. Fourth is isobaric. In isobaric, your pressure is constant. So work done is P delta V. Okay, simply P delta V. Then there were 2 or 3 more processes. First process being the cyclic process. Cyclic process, you just need to remember. In a cyclic process, for a cyclic process, you just need to remember that the change in heat or change in energy will always be equal to the change in or the total work done, because in a cyclic process your change in internal energy will always be 0 in a cyclic process. Then there can be a melting process or a boiling process. Apart from melting and boiling process, one most important thing based, like especially for your statement based questions, free expansion. Free expansion is basically total change in energy is 0. Du, delta U is equal to 0. Okay, so this is free expansion. Then there are two things, heat engine and Carnot engine and Carnot cycle. You should very clearly remember the limitations, because most of the times from thermodynamics, a statement based question might come, right? Refrigerator and heat engine, within heat engine, Carnot engine and heat pump. Okay. So today we discussed almost, I think, 10 to 12 chapters, right? And we are just left with 2 chapters from your class 11 syllabus, that is oscillations and waves. So for oscillations and waves, what we'll do is we'll cover it in the next class. So for oscillations and waves, what you have to remember is that you just need to remember the formulas, or the, like, in waves chapter, basically there are some formulas like organ pipe open at both ends, organ pipe open at one end. Just remember those formulas, like the formula for nodes and antinodes, those type of things. In oscillations, you don't have any specific formula, you just need to remember the the technique or the process to solve the questions. So make sure you do that. And like just a small advice for your, you people must be revising everything right now, because like today is 18th and your paper is on 21st. So because your paper, it starts at 2 p.m, you have that first half free, right? So do make sure that you just simply revise your formula copy on that day. don't delve into revising the complete notes, because you don't have to feel lethargic, or you don't have to feel tired just before your exam. Don't do like you just keep on revising and revising and revising since morning, and till 2 p.m. your brain gets tired. So don't do that, because your brain needs to be working at its 100% capacity, and you need to give your 100%, your best of the best, within those 3 hours of your exam. So make sure that you have your formula notebooks ready. Make sure of that. You have formula notebooks, you have your short revision notes, or even if you don't have your revision notes, you can just look for the mind maps. So we've also posted some videos on like wherein we are revising using the mind maps. So you can make use of mind maps at this point of time. Just a single page summary of the complete chapter, that will actually save a lot of time in your revision. So, wishing all of you a very best of luck. In our tomorrow's class, we are going to revise the chapters which we left off today, and then we'll start mainly with the class 12 syllabus. That is, we'll be starting with electrostatics, right? And we'll just try to cover all the. So, like this is a revision class, so we like I'll not be teaching you from scratch. We'll just be revising the important concepts. We'll discuss again. Otherwise, we'll just be revising the complete formulas. Okay, so hope you found today's class helpful. If you do so, then do like the stream, hit the like button, and thank you so much for watching. See you in the next class tomorrow, and wishing you all the best for your exam. I am very sure that all of you will do really great in your NEET